Hello guys, and welcome back to Study Star. Michael Mubanga, and in this video tutorial I am going to be talking about the last part of algebra. So the next part I'll be talking about algebra, maybe it will be when I'm answering some kind of exam question or something, but for now this is the last part I'm doing the actual teaching. So in today's video we're going to cover quadratic expressions and algebraic fractions. So let's jump right in. So what is a quadratic expression? Anything that has the form ax squared plus bx plus c is considered to be a quadratic expression. For example, say we have x squared minus 3x plus 2. This is a quadratic expression. C meaning 2, which has no x. B, there's 3, which has an x. And A, we have a 1 in front, which we don't show. So this is an example of a quadratic expression. Literally anything that has a squared, x squared or y squared, any variable squared is considered to be, which has any variable with the highest power being 2 is considered to be a quadratic expression. So how do we factorize quadratic expressions? So when we want to factorize quadratic expressions, we say there are 3 things we should consider, which are: first, we need to find the product. There's something we call the product, the sum, and any 2 factors. So the product, how do we get to the product? We get to the product by multiplying A times C, this times this. So 1 times 2 is 2, then that's our product. Then the sum, the S, is gotten by getting any number that represents the B, which is -3 in our case. That's our sum. Then the 2 factors, we find 2 numbers which when multiplied gives a 2, when added gives a -3. Those are -2 and -1. -2 times 2, that's 2. -2 plus -1 will give us -3. So those are our 2 factors. After we find the factors, then we say x squared. Then we replace where there was -3, we replace with these 2 factors. So this will be -2, we get the x, and -x, sorry, we don't show the 1, so -x plus 2. Then we factorize this using our data on grouped factorization. So x, we have x squared over x minus 2x over x, and we say which one is common between these 2. We want it to be negative here, so we say -1 is common, so that we have -x over -1 plus 2 over -1. Then we get x, this becomes x minus 2 minus 1, x minus 2. Then this becomes x minus 1, x minus 2. Then we have factorized this quadratic expression. It's as simple as that. So let's do another example. So let's say you've been given another example, which is 5x squared minus 4x minus 1. So the product in this case is 5 times -1, which is -5. The sum is -4, which 2 numbers are which when we multiply gives -5, and when we add gives -4. That's -5 and 1. This times this gives us this, this plus this gives us this. Then while there is -4, we replace with -5x plus x minus 1. Then we factorize this, so 5x is common in the first one, in the first set. 5x squared over 5x minus 5x over 5x plus 1 is common in this. We have x minus over 1 over 1. Then this is 5x. This into this gives us, these cancel each other out. We have x. This gives us 1. Then plus 1 x minus 1. So again, these should be the same. If these are not the same, then you're wrong somewhere, or you found the wrong factors. So these should be the same. Then we say x minus 1. Then the things outside, 5x plus 1, like group factorization, and we're done. So that's the second example. Let's do 2 more examples. So the third one, let's do x squared minus or plus 2x plus 1. Then again, we say what's the product? That's 1. The sum is 2. What's 2 numbers are which? When we multiply gives 1, when we add gives 2, 1 comma 1. Then we have x squared plus x plus x plus 1. Then x is common between these two, x squared over x plus x over x plus 1 common x plus 1 over 1 over 1. This one is the one that's being put below these things. So this is x plus 1 plus 1, x plus 1. Then x plus 1 are the things which are the same inside the brackets, and outside there's x plus 1. So this is our third example. Then let's do our final example, which is x squared minus x minus 12. So again, what do we do? So again, we say the product is negative 12. The sum is negative 1. Factors, which two numbers are which? When we multiply gives this, when we add gives this, we have negative 4 comma 3. This times this will give us that, this plus this will give us that. So x squared minus 4x plus 3x minus 12 will give us those. Then we say x is common, x minus 4 plus 3, x minus 4, then x minus 4, x plus 3. Then this is our factorization. So that's all when it comes to quadratic expressions, which is the factorization of quadratic expressions. Now let's move on to algebraic fractions. So what is an algebraic fraction? So an algebraic fraction is literally just a fraction that has some variables in it. So a good example would be x over 3 plus y over 5. By the way, these examples I'm solving, I'm just getting them from the study start tutorial on algebra, in algebra. So again, the same thing we do with those fractions is what we do with these. We say so we find a number where 3 and 5 can go without leaving a remainder. So instead of us hustling and trying to like find something, the lowest or the highest or whatever, we just multiply this and this, which gives us a 15. Then we say when you just multiply these two, you should automatically know that this will multiply this. So this multiplies this plus y, and this will also automatically multiply with this. Then we have 5x plus 3y divided by 15, and that's us expressing this as a single fraction. So you are going to be asked to say express a single fraction. This is us expressing as a single fraction. Another example is, let's say you've been given 3 over a b to the power 3 plus 5 over a squared b. So again, what we're doing is we're saying we're multiplying these two, a b to the power 3 multiplying a squared b. Then we're getting this 3, and this is automatically multiplying this on top, b plus 5, and this is automatically multiplying this, ab to the power 3, like that. Then when we multiply this, we're going to have 3a squared b plus 5ab to the power 3 divided by this, multiplying this will give us a to the power 3, and this multiplying this will give us b to the power 4, and that's us expressing this as a single fraction. Then the other one is, say you've been given 3 over x minus y plus 5 divided by y minus x. So again, we do the same thing here, which is we say this multiplying this will give us x minus y, y minus x. Then we say 3, we get this as it is automatic now. Then 5, this and this, x minus y. Then we multiply this, we have 3y minus 3x plus 5x minus 5y. So we collect the like terms now. So negative 3x plus 5x. Oh, sorry. We need to add the denominator, x minus y, y minus x. Okay, so we're adding the denominator. Don't forget that. Okay, so negative 3x plus 5x and plus 3y minus 5y divided by x minus y, y minus x. So when we operate on this, we have 2x minus 2y divided by x minus y, y minus x. But then again, we see that 2 is common between these two things. That means we can factorize the 2. So we see that we can factorize the 2. So our last expression looks like this: minus 2y divided by x minus y, y minus x. So 2 is common, x minus y over x minus y, y minus x. So these two things are multiplying with other things and they are the same. So this divide, we have 1 and we have 2 over y minus x as our final expression as a single fraction. So this video is taking very long, but anyway, let me just finish this. Okay, so finally, the last part of algebraic fractions I want us to cover is simplification. They say simplify, simplification. When they ask you to say simplify such an expression, such a fraction. So you've been given x plus y divided by 3x minus 3y and multiplying it with 2x minus 2y divided by 5x plus 5y. So what's going on here? So what happens here is we're multiplying these two things. So the simplest format I can advise you to follow is you just you like put these things in brackets, x plus y multiplied by, we factorize the 2 out of this, we get this, divided by, again here we say 3, factorize the 3 out of that, minus y, then multiplying 5x plus y. Then we see that this and this are the same, so these can cancel each other out, and these are the same, so these can cancel each other out, so that we have the ones multiplying everything on top. We get 1 times 1 times 2 times 1, which is 2, divided by 3 times 1 times 5 times 1, which is 15. Then we have simplified this expression. Then another example now has to deal with division. So say you've been asked to say simplify 6p to the power 3 divided by 7qr divided by 12p divided by 21q. So the first step is you convert the sign to a multiplication sign like you do with normal fractions, which is 6p 3 over 7qr multiplying 21q over 12p. So when you change the sign, these two things swap, these two things on the right hand side. So after these two things swap, you say 7 can go into 7 without leaving a remainder 1 time. 7 can go into 21 without leaving a remainder how many times? 3 times. Then q can go into q 1 time. Q can go into q 1 time. You are doing these things in like the opposites, the alternate sides. Then 6 can go into 6 1 time. 6 can go into 12 2 times. P can go into p 1 time. P can go into p to the power 3 p squared times. Then we say 3 times p squared, it's 3p squared divided by this times r, which is 2r. Then we have simplified this expression. Then finally, the last example I want us to handle is the following. Okay, so say you've been given x plus y divided by 2x minus y divided by 2x plus 2y divided by 4x minus 2y. So in order for us to simplify this, we first of all need to factorize the thing. So x plus y, what's common is 1, divided by what's common between these two, really nothing. Then divided by what's common between these two things, 2x plus y. What's common between these two things, it's 2, so we have 2x minus y. Then there's a multiplication sign. So what happens? So before we even do the multiplication sign, we can see that 2 and 2 can divide each other here because there's multiplication outside. Oh, the multiplication is inside, then these two are outside. This means this and this can cancel each other out, which gives us 1, 1. Then our expression looks like x plus y divided by 2x minus y. Then we're changing the sign. Then this is coming on top, 2x minus y divided by 1x plus y. So these two things are cancelling each other out. You can multiply then cancel, but this is the same. Just cancel this side and cancel this side as long as it's below. Then even these two things are common, 1, 1, 1, 1. We multiply this, we have 1 divided by 1, which is 1. Then this is how we handle such an expression. So this is everything on algebra, which is for grade 8s and grade 12s. So these last parts were for grade 12s, starting from grouped factorization. These things were for grade 12s only. So thank you very much, guys, and yeah, I hope I'll see you in the next video. This is the last part of algebra I am teaching. So thank you very much for tuning in to study stuff. And I hope to see you in the next video.